You see, quadrilateral means it is a four-sided polygon. Polygon with only four sides, we call it as quadrilateral. Okay. In that, there are four vertices A, B, C, D. Likewise, we have four sides also. The sides are AB, BC, CD, and DA. All of them are sides. We denote like this. Okay. In that, adjacent sides. Adjacent sides means what? There are two sides having common vertex AB and AD. Likewise, BC and CD, right? They are adjacent sides. Like opposite sides, sides which are not adjacent, they are opposite. Okay. So the opposite side of AB is what? BC. AB is CD. Likewise, the opposite side of BC is AD. Okay. Now, based on the behavior of these sides, we are classifying the quadrilateral into several types. Okay. Most probably, these opposite sides, these plays a crucial role. So, how many pair of opposite sides we have? Two pair. In the two pair, suppose if one pair is parallel, one pair of opposite sides are parallel, then the quadrilateral is called as trapezium. Okay. If two pair of opposite sides are parallel, then the quadrilateral is called as parallelogram. Okay. In a parallelogram, suppose all sides are equal. In a parallelogram, all sides are equal. Then we call it as rhombus. Okay. So here one pair is parallel means we mean trapezium that looks like this. These are parallel sides. Parallelogram means two pairs are parallel. These two are parallel and these two are parallel. Okay. And then rhombus, now all the sides are equal. It looks like more of a square. Okay. Clear? In a parallelogram, if only one angle is 90 degree, one angle 90 degree, then it is called as rectangle. How do we call it? Rectangle. Then all the other angles are 90 degree. In a rhombus, if only one angle 90 degree, then how do we call it? It is a square. Okay. Why I am saying all this? These are all not part of this. These are all previous knowledge, you should say. Suppose they may tell us to prove that this parallelogram is rectangle. What makes a parallelogram rectangle? We should know. Okay. Clear? So in a rhombus, adjacent sides are equal. To prove the parallelogram is a rhombus, what do we need to prove? Parallelogram already opposite sides are equal. So adjacent sides are equal, we need to prove. Okay. So you should have a clear idea about this. In this another type is there, but it's not as a part of NCERT. Like if the non-parallel sides are equal means how do we call it? This is a isosceles triangle. The isosceles trapezium. Okay. Got it? This is the classification based on that. So the quadrilaterals is of two types, majorly trapezium and parallelogram. By adding one and one condition, we may classify that into these types. Now in this, throughout the chapter, we will be focusing on the parallelogram. Okay. So the properties of parallelogram, that is what we are going to see, right? Yes man, right man. I simply wrote what are all the sides, what are all adjacent sides, what are all opposite sides. Finish writing, come on. Shall I erase one side? This side. Okay, good. So the properties of parallelogram, like how they proved. Sometimes we may be asked to prove that one also. We have to be ready for that. Simply I'll say, just try to understand. I'm giving everything as a properties of parallelogram. Okay. So the diagonal divides the parallelogram into two congruent triangles. How does it happen? This is the diagonal. These two triangles are congruent. How we can prove these two are congruent? You know, this DC and AB is parallel, right? What they say? AB is parallel to DC and AD is parallel to BC. Now what you can say about these two angles? What you can say about these two angles? This AC acts like a transversal. Remember, lines and angles. These are alternate interior angles. And alternate interior angles are what? Equal. Likewise, the other pair is for this one. But this time parallel lines are these two, AD and BC, not these two. Why, can you tell me? This double line is for AD and BC, not for the same line, because this is not completed, this is not touching the line again, we can't say. So because of these two only, AD and BC, this angle is coming. AC and this AB and DC, this angle is coming. Got it? And this side is common. Then what congruency? ASA congruency. So when these two triangles are congruent, shall we say the corresponding sides are equal? Then that brings us AD equals BC. Got it? Is it or not? So opposite sides are equal. In a parallelogram. Got it? And the third one, in a quadrilateral, if opposite sides are equal, then it is a parallelogram. Got it? If it is already a parallelogram, we can say opposite sides are equal. Suppose it is only a quadrilateral. If opposite sides are equal, then we can say it is a parallelogram. Got it? Now, I said these two angles are equal, right? These two angles are equal. Just add these two. What you will get by adding? Angle A fully you will get. Here angle C fully you will get. Is it or not? So that gives us the another identity, another property, that the opposite angles are equal in a parallelogram. Guess what? What makes a quadrilateral parallelogram? Based on this property. Will I erase this? Based on this property. Can you tell what would be the reverse, you know? In a quadrilateral, the property 5, in a quadrilateral, If opposite sides are equal, opposite angles, then it is a parallelogram. Got it? And then sixth one, the diagonals bisect each other. In a parallelogram, the diagonals bisect each other. What would be the seventh property? Can you guess something? In a quadrilateral, come on, there you go. In a quadrilateral, if diagonals bisect each other, then it is a parallelogram. Okay. Any doubts on this? Any doubts on this one? Okay. Now we'll start the example one. Show that each angle of a rectangle is a right angle. There you see how we can prove all this, you know that, right? This congruency itself, I gave the idea of this. All the four will come, right? But it depends. Whenever it is required to prove, will you be able to prove? This in the quadrilateral things and all, because of the opposite sides are equal, we may have to find something to make these lines are parallel. Okay? That like we have to prove. Proofs they may not ask, but you have to be aware of the proof if possible. Okay? Shall I erase everything? Everything, man. Okay. This side shall erase. Okay. Make it fast. Okay, good. Now the example one, prove that all the angles of rectangle is right angle. What is that to prove? Huh? What is that to prove? We already know all angles of rectangle is right angle, 90 degree. Is it or not? Then what is that to prove that? Come on, say. So consider a rectangle. ABCD as per tradition. ABCD is a rectangle. Okay. And we know AB is parallel to DC, right? AB is parallel to DC, we know. Then that means this AD is a transversal. Imagine this transversal. Then these two angles are this angle A plus angle D is equals 180 degree. Angles in the same side of transversal, remember? Okay. So angles in the same side of the transversal 180 degree. And we know that rectangle na in a parallelogram one angle is 90 degree, right? It is or not? So initially itself, in which angle A is equals 90 degree, let us take. So that makes from 1 so 90 plus angle D is equals 180 degree. Then we have angle D is 90 degree. Similarly, angle B and C. Angle B plus angle C is 180 degree. See, so far I gave you 7 results. In that, none of the results gave you that sum of adjacent angles is 180 degree. Remember? That is also a hidden property. Sum of adjacent angles are supplementary based on this transversal concept. Okay? So, not BC, we will take D and C. D is 90 degree, we know, which implies angle C is 90 degree. And similarly, we have angle B is also 90 degree. Got it? Any doubts on this? Therefore statement. What is a therefore statement? Therefore, all angles in the rectangle are right angle. Okay. Show that the diagonals of a rhombus are perpendicular to each other. Diagonals of rhombus are perpendicular to each other. To prove this, what do we need first? We need a rhombus. First we need what? A rhombus. So consider a rhombus. ABCD. Okay, we can draw that. Let this diagonals AD and BC intersect at O. Diagonals AC and BD intersect at O. Then we need to prove their AC is perpendicular to BD. We need to prove. That is, any one angle we can take. Any one angle we can take. That angle is 90 degree, we need to prove. That means here I am fixing this angle. So DOA is 90 degree. If we can able to prove, means that would be enough. Now, since it is a rhombus, we have all the sides are equal, that we already know. What are all the linear pair of this angle? This is one linear pair, this is one linear pair. If you can able to prove any one linear pair is equal to this angle, then automatically it is 90 degree. So I am choosing this one. Okay. So these two triangles, we should say it is congruent. Okay. How we can say these two triangles are congruent? How we can say that? Simply you are moving without even saying. Nice. Nice gesture. Thank you. See, these two triangles, let me take. So, in triangle AOB and triangle AOB na AOD will take. AOD. List out the common things. Obviously, AO is equals AO. It is common. And then AD is equals AB, shall we say? No. AB equals AD. Okay. So those are sides of rhombus. They are equal. Any other things are equal? OB is equals OD. How, sir? Because it is a parallelogram. Parallelogram? Is this parallelogram? Is rhombus a parallelogram? अरे क्या भाई? Is rhombus a parallelogram or not? Initially I gave one mind map something. See, in a parallelogram diagonals bisect each other. Remember, the parts of diagonals are equal. Doesn't mean the diagonals are equal. These bisected parts are equal. So we have diagonals of parallelogram bisect each other. Okay. Any doubts in this? Any doubts in this, Ram? Okay. Now what congruency it is? SSS congruency. This triangle AOB is congruent to triangle AOD. That makes these two angles are equal, right? Shall I erase the first half? Come on, write first. Have they started this chapter in your school? Okay, good. Okay, then why we have to take this again? Not necessary, right? Still 3 more examples are there. 3, 4 and 5. If you are okay with the examples, then we can go to exercise. Go through those examples, those who completed. Tell me if you are okay with that, then we can move to the exercise. Not a problem. Make it fast. this side. Good. So by triple S congruency, we have proved that this linear pair angle are equal. So then we may say angle AOD is equals angle AOB. No, AOB equals AOD by CPCT, corresponding parts of congruent triangles. But we have this angle AOB plus angle AOD is 180 degree. They are linear pair. Okay. So 2 times which angle? DOA I took. DOA na AOD, both are same. Equals 180 degree. That gives us angle DOA is 90 degree. So therefore, diagonals of a rhombus are perpendicular to each other. Okay. Any doubts on this? Yes. Shall we go to next example? Shall I erase everything? Shall I erase everything? Tell me when you finished. Okay, everything. Everyone completed. Good. This side. Okay, example 3. I told you all to take a look at example 3 and let me know whether you are okay with that or not. If you are not okay, then we will continue with the examples or else we will continue with the exercise. See the example 3. The example 3 they gave ABC is an isosceles triangle in which AB is equals AC. AD bisects the exterior angle PAC and CD is parallel to AB. Okay. Then we need to show that DAC is equals DCA. We'll draw the diagram and we'll discuss in short. Okay. Just tell me whether you can understand this or not. ABC is an isosceles triangle in which AB is equals AC. Just like we are extending D and this is connected. This is external angle P. This is also equal to this. Okay. Then DAC equals angle BCA. Where is angle BCA? This angle. This is DAC. These two angles are equal. We need to prove. Okay. In short, I will tell you the walkthrough of the proof. See, this angle B is equals angle C. Correct? Because it is opposite to equal sides. AC na, that is ACB. Okay. Now we need to connect this angle with this angle. Anyhow, these are related? No, this is not related. This guy is bisector. So I am going to take this full angle as an exterior angle. Remember exterior angle some property studied in 7th class. You all studied 7th class, right? Did you study? Exterior angle some property. This angle PAC equals angle B. This is exterior angle B plus angle ACB. Okay. So these two are already equal, right? So instead of these two, any one we can substitute. What do we need first? This angle B we need or this ACB we need? This angle B only we need. That is ABC. Correct? So 2 times angle ABC. Also, this PAC is full angle. That means these are equal parts. This guy is bisector. AD is a bisector, right? So we can write 2 times angle DAC. So 2 cancel. Angle DAC equals angle ABC. That is it. This is the idea. Have you understood or not? We need to connect these two. What are all the possible ways? That ways we can do. Okay. Likewise, any doubts on this? Example 4. Any doubts on this, man? No. Okay. In example 4, 2 parallel lines L and M intersected by the transversal show that the quadrilateral formed by bisectors of interior angle is rectangle. Clearly, in this question, diagram is given. 2 parallel lines L and M, they intersected by the transversal. Transversal name is P. Interior angles. What are all the interior angles? These are all interior angles. Let me name it 1, 2, 3, 4. Okay. Now, the bisectors of the interior angles. So, the bisectors of the interior angles means this angle 1 will draw a bisector, this angle 4 will draw a bisector, for this we can draw a bisector, for this we can draw a bisector. Obviously we have a quadrilateral, let us name it ABCD. Okay, this is quadrilateral ABCD. This quadrilateral is a rectangle we need to prove. Okay, to prove a quadrilateral rectangle, we need to prove that it is a parallelogram first. Then after that, one angle 90 degree we have to prove. Okay. So this is angle 1 that is equal to angle 3, right? Angle 1 is equals angle 3. Same way, half of angle 1 is equals half of angle 3. That means this half and the other half. This is still a transversal. So that makes AB is parallel to They are alternate interior angles of the transversal. Welcome back, sister power. Are you all right? Okay. So AB is parallel to CD. Likewise, the other one also. Could you please mute yourself? And then this angle 2 is equals angle 4. Same way, half of 2 is equals half of 4. This half is equal to the other half. That is still a alternate interior angles. Then we may have this BC is parallel to AD. So opposite sides are parallel. This is a parallelogram. Okay. So one angle is 90 degree we need to prove. We know that angle 4 plus angle 3 is 180 degree. They are linear pair, right? These two are linear pair. Take half of it. Half of 4 plus half of 3 equals 90 degree, right? That means this angle BCD, half of 4 plus half of 3 na this angle. So parallelogram, opposite sides are parallel and then one angle 90 degree. Therefore ABCD is a quadrilateral. Quadrilateral. Is that a quadrilateral? Shall I erase this? Die. So nobody is listening. What do we need to prove? It is a rectangle. Okay. We finished. Sorry, I finished. After finishing, I said this is a quadrilateral, like I said. Focus, man, focus. Where is the other guy? See, next one. Example 5. Show that the bisectors of the angles of parallelogram form a rectangle. Same like this. Instead of the parallel lines, we are proving inside the parallelogram. So ABCD is a parallelogram. These are all bisectors of the angle. So this is PQRS is a rectangle we need to prove. So let me take it as ABCD. Instead of taking it directly, I am going to take this angle is 90 degree. If I am able to prove means, we can say it is a rectangle, right? This angle 90 degree, you have to say this angle 90 degree is you can say. That is enough. Okay. Okay. Then see this half of A plus half of B. Half of B equals in this triangle you can take this triangle PAD. Half of A is there, half of D is there, plus this angle APD is there. By angle sum property we get 180 degree. Okay. Now half of A plus D is how much then? A plus D, they are adjacent sides, adjacent angles. Adjacent angles are supplementary in the parallelogram. So A plus D 180, na, this one how much? 90 plus APD equals 180 degree. So we have this angle APD is 90 degree. APD na this angle. So is this angle P. Because they are vertically opposite angles. Okay. Similarly, we can prove in this triangle half of C plus half of B. So this angle also what? Okay. So angle S is also 90 degree. Now sum of opposite angles is 180 degree. Opposite angles are equal. Remember properties of a parallelogram. If opposite angles are equal in a quadrilateral, then we can say it is a Parallelogram. So it is a parallelogram. So in a parallelogram, one angle is 90. Technically, it is what? Rectangle. That is all. Still you are saying parallelogram. So that is it about these examples, and still we have 7 questions in the exercise that we will complete tomorrow, and then we have still one more exercise. That is easy only. Then the class will finish. Okay. So any doubts or clarifications in this? Okay, good. So far, what are all the things we have seen? Can anyone say?